And today we're looking at this pump. This is a surface mount pump. Sits on a floor, often used in restaurants where you have to pump water up to a certain level before you can get to a drain. So the problem that we're facing is, you see the cord coming into it, it's all frayed up, and should be changed. It looks like mice went at it. So if you look at this connector here, you see two wires going into three prongs. Inside the pump there's this thing called a float. The float is basically a switch. When the fluid level reaches a certain height, the float will tip and activate a switch internal to the float, and it'll make the circuit. It'll complete the circuit, providing 120 volts in this case to the pump. So one of these wires goes directly to the pump motor, and then one of these wires here goes to the float switch. So if you don't know which one is which, you could open it up. There's access into the pump there, and trace it back, but you don't have to do that. I'm going to show you how you can figure out which one is the switch and which one goes directly to the motor. So I'm going to pause the video. So I've stripped the wires, and you can see one has two conductors in it and one has three conductors. So how do you know which one is going to the motor, which one is going to the switch? In this case, I'm almost certain that this one here, the one with the two conductors, is going to the switch, and then the one with the grounds is going all the way back to the motor. But if you really want to double check, get a meter, like a multimeter like this, something that has ohms setting. Ohms will check for continuity, and I've got it set to the beep setting. So when there's continuity between the red and the black on the leads going into the meter, you hear it beeps. So now I'm going to transfer my meter to the white and the black of the wire where it only had two, and my meter shows open. There's no continuity there. That's because the switch inside the pump is off, or there's something wrong with the motor, but I know there's nothing wrong with the motor. It works. So this is genuinely off because the switch is off. Now I'm going to check the resistance of the other cable, the one with the three. I'm going to put my meter leads on the black. Polarity doesn't matter when you're doing continuity checks like this. I don't know if you can hear it there, but there is continuity there. I'm registering about 4.4 ohms or so, which means it's not a dead short, and that to me says that we're looking at the two wires going into the motor windings. So here's a schematic I drew, which is how I'm going to put all this together. So these two wires, the black and the white, are the cable with just two. So black and white are going to go there, and then our 3 is going to go black to that white, and then the white from the outlet, from the electrical source, goes to the white of the 2 conductor and gets tied in also to the white going into the 3 conductor cable, and the ground just gets followed all the way through. Here's our motor winding, and that's why we registered 4 ohms or so when we checked it with the multimeter. That's a dead giveaway there. That black and white pair is the actual motor. So now I'm going to show you what I did with all these wires and how they're all intertwined. So this is a utility box because the old molding is all no good anymore. So this wire here is going to get plugged into the wall outlet just by one of these plugs. The black wire goes to the copper screw. The white wire goes to the silver screw. But don't just depend on the color of the screws, in case the screws can be interchanged. The way I remember it is, if you're plugging it in this way, the ground is on the bottom, the left hand side is always supposed to be neutral. The neutral wire, which is the white. This particular plug, the blades are the same size, but if you look on the receptacle, one side the blade opening is a little larger, and that's the neutral. And then I'm going to close this up. On the other side here we have 2 wires. These are the 2 wires going into the pump, one being the switch and the other one being the motor winding. So you're going to wire it up according to this diagram here. It's hard to see what's what inside the box like this, but one thing very, very important is this box has to be grounded at all times, this electrical box. So you just put a piece of copper wire on that screw that bonds this wire to the casing, and then tie your grounds, in this case the ground coming from this side leaving to this side. Just going to tie them all together, but it's crucial that you maintain a bond in there. You can't just tie the green ones without grounding the box itself, because if by chance the box becomes live and it's not grounded, the circuit breaker will not trip. Somebody touches that, they're going to get zapped. So the switch is this pair of wire, this one and this one, white and black. And then the motor cable is this side, white, black, and ground gets followed through all the way. One thing I don't show in this diagram is the case. So just remember, the case also goes to ground. That's case is this. So now I'm going to close it up and we'll give it a whirl. Here's the finished product. Nice handy case. You can mount that to the wall or tie wrap it. You can screw it on the wall if you like. and this side here, going in there and then leaving here. So when the float, when the water level reaches a certain point, the float inside will start rising like this, and then inside the float there's a ball. The ball goes backwards and makes contact between two prongs, and and that completes the circuit, joining, which in effect electrically joins these wires to the motor winding. Hope you found that useful, and any comments, if you don't disagree, if you disagree with something I did, I welcome all comments, good or bad. Yeah, you can just hear right now kicking in.